All right, I know that, I think it was even yesterday that I talked about our position in the class and what we're going to be doing, but since then I've heard some whispers of wanting some applications of the material that we're doing, so it's not just lecture, and that was in the plans, but now I want to communicate to you what the next few weeks are going to look like and what assignments are going to start looking like when they're going to be assigned. So starting next week, we're going to be diving into design patterns, and each design pattern that we cover, not quite every single one of them, but a subset of them are going to have some very small labs associated with them. These are very small in scope, and I expect them to not take most people more than an hour or two to implement. It's mostly apply this yourself, this concept yourself in some toy situation. Those will be the small labs, and there will be larger labs that deal with combinations of design patterns where you're going to need to be applying multiple of them in the same overarching lab. So there will be some problem and you'll need to be implementing multiple design patterns to solve that problem. And some of these labs will probably overlap just because we will be covering something like 10 to 12 design patterns. And I plan to introduce them in groups of 3. And then there will be a larger lab for each group of 3, and then smaller labs for some of the more difficult, or at least the first few smaller design patterns that we cover. So that's the plan. We're not just going to be doing this the entire class. I want you to get some experience in this as well. So that will really start as we start going through the design patterns. Any questions on upcoming work or anything else about the class? It's been nice and relaxed so far. Actually, I really appreciate the relaxed nature that we've had so far. I think that's good, but you do need some application. So that is coming. And that is coming very soon.
Will there be a team project?
There will not be team projects, as far as I know. Maybe something at the very end of the quarter where you could design something with multiple groups of design patterns, if I can find a way for the larger projects to connect to each other in some way. We'll have to see what I can come up with. Basically, this course has very little prep for it ahead of my teaching it, and the feedback that I've gotten from upper division students are basically 212 has no purpose, we hate it, we don't remember anything from it. So I'm trying to make it more memorable, but also get those same outcomes together. So because of that, I'm not using a ton of the prior content that has been done in this class. So I'm working on redesigning it. So you all will be the guinea pigs as I start to do that redesign. As part of that, I'm very open to feedback. So if you find some assignment not particularly useful or very useful, that's the kind of information that I want to know. I'm teaching this one more time next quarter, but after that, I'm probably not teaching it again. But I'd like to pass on to the next person who teaches it some knowledge about what students actually liked about it. So it's not just a bunch of upperclassmen complaining about the class. That's not particularly useful for the new design of the course. So that's what I'm looking for, is good feedback of ways to make this course useful, relevant, applicable, and not just boring. What am I doing? This is what I'm doing. So I didn't really want to dive into design patterns for one day this week before we do kind of the fun. So we're going to be doing programming problems for a couple days at the end of this week. And then we'll tackle fresh on Monday and start in on our first group of design patterns on Monday. So we're going to start getting a bit more 210 experience with arrays. And so some of the array work is going to be Project Euler's problem 8, and I think it's problem 11 or 12 that we're going to try to cover today. So the first one-dimensional arrays. We are going to look at this following massive set of numbers. We're going to be looking for the largest multiplication value of 13 consecutive numbers in this long sequence of numbers. It tells you that the 4 adjacent digits with the largest product are 9, 9, 8, and 9. I think that occurs right here. But you can see there are zeros on either side of it. So this solution will not be in the list of 13 with the highest product. So the question is, what algorithmically could we do? And the other reason I wanted to choose problems like this is you can copy this and paste it into a text file and then parse the text file as part of this. So we can get some practice with opening and reading from files, which I know is on the 8. A lot of you are taking the 8, so this would be good practice for opening from and reading from a file. So let's get started with this. I don't want to spoil too much before we get started, but find yourself at least one other person to work with and see if you can crank out a solution for this. The way you're going to do it, go to Project Euler, grab this entire bit of text, copy it into a text file, and then use that text file, read from that text file in the program that you write. In a few minutes, I'll get you started on that process. I see some people starting to work together. If you don't have someone to work with, go find someone to work with. Much better in pairs. Trying to hide Jimmy. Yeah. I think it's just. Yeah.
So maybe we can like put like a step in the code that just gives me that. Without. Like, you know, we build it first.
Yeah, just implement a file.
Still.
Take off of that.
Well. If there's a 0, 13, skip to 1, that's zero. That's true. So all the applications, that's that. Is that a 0 shows as well?
Yeah.
I mean, we already know what 5,000, and then the 0 shows it. It's a skip. So like, I don't think it's a possibility.
How will you parse it this? Do you want text file, CSV?
Yeah, so I guess every
No.
time you have to check. Split on. Yeah, every time. How do you store exactly where the what segment falls? It's not that fast, but the store is. Use that as like it's a object. And also these out of this.
This is probably.
Yeah, there's a
Uh,
map language, there's a. I think it's just like an X between two values. I think that's to be honest, it's gonna be a pseudo.
And then you just,
You take an A for it.
Yeah.
I don't think you can do that.
just do the first year.
Not so.
Yeah. Interesting.
Back in.
I am looking at the making these ourselves 2 months.
No, no.
Exercise.
Yeah, yeah.
Yeah.
There's one thing missing from this line, what is it? We need someone to determine if we're reading from or writing to this file. What is the syntax for that? Where does that go? Yeah. Scanning files in Java, scanning anything in Java is a little bit harder than it is in other languages. So a couple things I want to point out, you need to make sure that your main throws file not found exception. Otherwise, you will not be able to open this file. The other thing that you could do is surround this with a try catch that catches a file not found exception, but that's just unnecessarily verbose. That would be necessary if we wanted to do something if we got this file not found exception, but because it happens immediately in the program, if you just say throws file not found exception, you're basically telling the compiler, I'm okay if you just crash if we can't find this file. And that's perfectly okay, but in an instance where you did not want this to crash, you would want to surround this with a try catch. So what do we do? Where does it go? How do we determine if we're reading from or writing to a file? We obviously want to read from this file. We don't need to modify any of this content, but we need to represent this content in our program somewhere. How do we syntactically represent whether we're reading from or writing to a file? Is that gonna work? Is this everything that we need to make a scanner over a file? If we didn't know the answer to this, how could we find it out? Go to some tab. Java. Reading a text file using a scanner class in Java. Stack Overflow is usually a great place to go. And an answer. Do we need to determine? That's kind of in the way of the code that I've written, I apologize. How can we, there we go, that's a little bit better. Do we need to determine reading versus writing? Is there anywhere in that code that tells us that? The scanner goes from system.in, but that's the terminal. So basically, we have a choice when we instantiate a scanner of where is that scanner reading from. System.in tells us we're reading it from the terminal. When we pass this scanner, basically I'm taking the code from that Stack Overflow and kind of crunching some of the lines together that says this scanner is going to be instantiated by looking at this file object. This file object needs to get everything from input.txt. So this is everything that we need. We don't need to worry about reading versus writing. If we had a buffered reader or buffered writer over this instead of a scanner, I just don't like using them. A scanner does everything that you need. Then we would have to worry a little bit more about it. And it makes the syntax a little bit harder. But for a scanner, this is all we need. So now that we have a scanner looking at this file and the file is pointing at this text, note that where does this file need to be in order for you to use it? That's another good point that we should go over. Yeah, needs to be in the same directory as the code. This is a relative path name. So if you had it somewhere else, you would just have to give the associated relative path. Have we seen the difference between an absolute path and a relative path before? Some other class?
But is it different from like other Other programming language where you use dot dot.
It is not. Yeah, you just say dot dot slash to go up a directory. So if, for instance, this is where your code is living. If you were to put it in the folder above that, you would say dot dot quote dot dot slash input dot txt quote. And that would let you go up a directory. If it was in another subdirectory that was, let's say, here's where your code lives. Dying on me. No. Usually better than that. Oh well. This is where the code lives. And then you go up a directory and down another directory, and then here's where your file is. And let's say this folder is called, what do we want to call it? Inputs. Then you would want the relative directory. From here, you go back up to and then we called it input.txt. So that's how you would go up a directory and then down a directory.
Would, for the extension, would actually the wildcard work here as well? Like, maybe like for the name, if I want to put an input, be like this.
No, because that might match to multiple objects. You might have multiple things that start with, that are in this directory, if you just said /star. So it's actually gonna look for a file called star. So there's no way to tell whether you're using the wildcard or whether you're searching for a file that has the same name as the wildcard. So yeah, wildcard will not work here, but that's a great question. So this helps us get everything that we need, helps us to be able to find it. It's easiest to just drop this txt file in the same directory, so you don't need to do any of these shenanigans to go find it. If you have it in the right place, this will work. If it is not in the right place, you will get the file not found exception and your program will crash. So if you try to run it just with this much information and you get a file not found exception, the file's in the wrong place. Play around with where you can drag and drop it. It should be in the same project as all of your, it should be in the project directory. All right, now that we've imported our file, how do we actually start with the logic to parse it? We have a scanner pointing at the file. In broad English, how do we want to tackle this problem? Grab the whole thing as a string, and then maybe try to character by character put it in an array? Or do we want to start parsing the strings?
Just, yeah, parse the strings and then do substrings.
How are you going to convert them into integers in order to multiply them?
Integer, not parse it. Oh, I see what you're saying.
Yeah,
I was gonna do modulus then.
you could do that to break apart, but I think it might even be easier to read this character by character.
Oh, yeah.
So we need to grab this line at a time, but for each line, we could start parsing that character by character. Does that make sense? So we want to start by looking at this 7, but this file is going to be read in as strings. I mean, we could read it as next int, next int, next int, next int, next int, but then how do we know when we're done? I guess we could say as long as there's another int to read. So a scanner has next int. But we need some way to read it in from the file. So we could say something like, how do we want to do this? We probably want to make this a new function. So this should be the end of this function, and we should pass the file object, the scanner onto some new function. So some new function. It says, well, there's another integer to read. How do we want to do this? So some inefficient ways. We could make an array of size 13. And then every time we read a new number, we would have to delete what's in the first one and just kind of start replacing what is currently in index 1 goes in index 0, what's currently in index 2 goes in index 1, what's currently in index 3 goes in index 2, and you just move everything over, making room for the one new number you're going to read. Multiply that all together, come up with the product. Does it seem efficient? What's something smarter that we could do? I'll leave that brewing with you for a while. Think about this with whomever you're working with and see if we can come up with something smarter to do here. You may want to use this loop as next int. You may want to use a loop that looks like using has next. What would has next do for us? Remember that has next grabs the next token. What is a token in this file? Yes, it is every line. So has next will grab this entire line as a single string. So you will need a string variable once you go actually call .next. It's important to make sure there's another line to grab, which is why we use has next, or there's another int to grab, which is why we use has next int. But inside of either one of these loops, we would want something like next int to actually grab it, or next to actually grab the entire line as a string. So design options now. How are we going to efficiently parse this? What structure should we use? Should we use an array? Should we use an array list? Should we use some other kind of custom structure? Should we write a class for this?
So, we can maintain those expectations of us that they- Yeah, sure. So I can just call them for a thing. Yeah, I think I should do this. That's very good. Yeah, just about that. But when we go back, just to show their page of the traffic, what's going to be. What's going to be easier, but it's going to be very, it's the way we can go. So then I'll just basically be about the same thing. It's the answers. Yeah. So there's a really no thing she's doing. This is the same. Line. That's just yeah, one thing to pick up inside. That sounds like the distance. Yeah.
It's actually just slightly differently. Slightly different.
So that's, yeah, that's the ones you can just follow. That's. And, character. String. Surrounded by parsing, doesn't it?
Ugh, Java. Parse the string that is. What do we think? Sanity check on some of these lines? I heard someone say they were fighting with a scanner. Anything I can help with?
The like location
The file.
for the import is just not what's up there. I just forgot what it was.
All right, so let's talk through this logic that's going to make a single array list of all of these numbers. So basically this outer loop is saying, well, there's another line to read. Read in that line. Then we have that line, so we're gonna say for each character in that line. So I originally had a for each loop here and then refactored it into a regular for loop. Because if we use a for each, then we're guaranteed to get a character object. And there's no easy way to parse a character into an integer, at least that I know off the top of my head. There probably is. I'd have to look up how to do it. So what next occurred to me was, all right, so we can set a counter variable starting at the 0th index and counting up, well, it's less than the length of the line. Then we can take the substring that is just that character, that returns that as a string. Integer.parseInt allows you to turn a string into an integer. So this gives you the single digit and says the integer representation of that single digit, now add that to the array list. So that's basically now saying there is an element of the array list that is every element of this. Since add adds it at the end of the list, it's going to do this for every integer in this first line of integers. And then we'll loop around and grab the next one, and grab the next one, and grab the next one. And this grabs it line by line, and then character by character adds it to the array list. By the time this nested loop has finished, and this while loop should now be terminated as well, we're going to have in this array list at index 0 is this 7, index 1 is this 3, index 2 is this 1, index 3 is this 6, 4 is the 7, 5 is the 1. And when we get to the end, we're just going to loop around and the very next element will be the next element. So this is no longer a two-dimensional object. We've squashed it into a one-dimensional object by just making all of these objects, or all of the parsing all of this. Do people follow? Does that make sense? So that's the intuition here. Oh, we have 10 minutes. So now we need to figure out, given that we have this array list, how are we actually going to parse the array list to answer this question? All of this has just been trying to figure out how do we get this representation in an easy internal way that we can now parse to be able to answer the question. Is this I? This goes up to, but not including. This may be I plus 1. Play around with it. Yeah, it's up to, but not including the last one. I'm pretty sure this is actually I plus 1. All right, any intuition, now that we have this array list, we have this one single long, I'm just gonna kind of draw it like this. All of this is now embedded in a single long array-based form. What do we think we should do? We're kind of gonna have a length 13 substring of this, or sub element of this that we want to turn into a product of some kind. Is there an easy way to do this? You could multiply straight across, get a product. How could we figure out what the next window of this is? So we need to figure out what this product is that ends here. We need to figure out what this product is. We need to figure out what this product is. We need to figure out what this product is. Rather than multiplying something through 13 times, a bunch of times, is there any way we could shortcut this to just take into account the next element of the list? We want to somehow get rid of this object. So for sanity's purposes, I'm gonna say all of these elements are twos to give us an idea of what this might be. What would the product be of the first 13 twos? We represent it as an expression, it's 2 to the 13th. 2 times 2 times 2 times 2, 13 times. How could we, assuming that this next element was now a 3, how could we incorporate that into this product?
Because you multiply by 3 and divide by 2.
Multiply by this number and divide by the first index. That seems like a pretty good idea. Is there any circumstance where that might lead to something we don't want?
Well, you might want to divide by 2 then.
I think this will work in this particular situation, but I would argue that there is a situation where multiplying this and dividing by this crashes your program.
0.
Yes, if this first element is 0, we will end up dividing by 0. So we want to conditionally do something if this first element is 0 as we pass this sliding window over this array structure. So I'll leave it to you how you want to handle that issue, but it will crop up. In order for this to even be a 0, there has to be a 0 in this. So one thing we could do about this is whenever we see a new 0, just move the entire window, slide it over 13 spaces, because every product that 0 is in is going to be 0, right? So we don't need to consider any of those. So we could instead just start moving that window and then multiplying through. But what if that multiplying through after we move the window contains a 0? We would need to figure that out and then move the window again. That's going to be a little bit of extra logic. This is something that I think the early Eastern classes don't quite teach well enough. This all uses the tools that we've all seen before. I don't think there's anything new in here, right? Has everyone seen all of the associated functions in all of this? We've seen substring, we've seen parseInt, we've seen array lists add, we've seen a for loop and a while loop and a scanner and a file object. It doesn't really use anything that you haven't seen before. But being able to apply this to a problem that you haven't seen before that uses all of these concepts, it's not as formulaic as just here's information. You actually have to use critical thinking and problem solving to figure out how do I bunch all of these together into a logical sequence that solves this problem. maybe we should just start by writing a solution that doesn't concern itself with trying to avoid zeros. Zeros is a perfectly natural thing that can occur. We're just going to continue to multiply every possible window here. Is that computationally infeasible? Is this something that will cause our program to not be able to finish in a reasonable amount of time? How could we do that analysis?
Using a brute force there.
So we basically have however many characters this is, it's a 1,000-digit number. So we're gonna need to analyze and multiply the first 13 numbers, the next 13 numbers, the next 13 numbers, the next 13 numbers, etc. That's bounded by multiplying everything by everything else. It's less than that problem, right? We're not multiplying everything by everything else, it's just windows of 13. So multiplying everything by everything else would be 1,000 times 999. That's less than 1,000,000. 1,000,000 computations is a fraction of a second. So yes, that's brute forcing. Yes, there are faster, more efficient ways that would use some more code, but any modern CPU should be able to brute force this problem. Which says that if it saves us a bunch of time, it's not worth considering optimizing this. So even though we could optimize it, it's just straight up not worth it. It will make your program go from instant to slightly more instant. For all intents and purposes.
This particular problem, you can skip all the number that is not nine. Start with all the number that start with nine, right?
Well, what if you had 8, and there was no 9 with, you're making an assumption there that is probably true for this, probably? Maybe? But I don't think a proof for any particular 1,000-digit number that would always produce the right answer. How are we doing? Do we feel like we know how to proceed? Would we be able to finish off this program if you had another hour? Since we are basically out of time, my recommendation is, since you don't currently have an assignment in this class, try to finish this off. Try to come to class tomorrow with a working version of this. Have this solved in Project Euler by tomorrow's class. We're gonna do a very similar type of problem that uses a 2-dimensional array instead of a 1-dimensional array, and we'll worry much more about index out of bounds exceptions tomorrow, which I think is the bane of a lot of introductory students' existences. So we'll go over that and make sure that's fresh in your minds tomorrow. All right, have a good day. Thank you.